Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with the various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Coming to this program, I am presenting here with a series of lectures on refrigeration systems for the benefit of the students and professionals. I believe these lectures will be of great help and learning to all of you. This is the 5th lecture in the series of lectures on refrigeration systems. In this lecture, I will explain you the process of doing engineering calculations in refrigeration. Let us start with what we were discussing in the previous lecture. That is, we had one simple VCR cycle plotted on pH diagram and then we dropped all the state points onto x-axis to have H1, H2 and H3. From this, we got RE, W and HR, which can be expressed like this. And finally, the COP was computed using this expression. Therefore, we can clearly understand from this discussion that if H1, H2 and H3 are available with us, then we can compute everything that is needed here, namely RE, W, COP, etc. Let me give an interesting perspective here. If we are given all the data and all the information that is needed to solve a problem, then can we call that as an engineering problem? The answer is no. Please understand that no engineering problem will ever come to us with all the information offered on a platter. Then how will that be? This is how an engineering problem will be coming to us. The problem statement consists of generic information in the form of requirement. We need to make use of the property tables or data book, etc. and then apply our engineering skills to find a solution to this problem. Let us look at that now. In this case, we are given either PC and PE or TC and TE along with the name of the refrigerant. We need to pick up the data from the property tables of that particular refrigerant. We need to collect the enthalpy of saturated liquid and saturated vapor corresponding to PC and PE. Similarly, entropy of saturated liquid and saturated vapor corresponding to PC and PE. Then, the specific heat of the vapor corresponding to PC. There is one important note point here. All the property values must be taken from one source only. Otherwise, our calculations could go wrong. So please be aware of that. The next step is engineering analysis. Here, we will understand what is the data that is available with us and what is not. Let us start with pH diagram and we will plot PCPE and TCTE on this pH diagram. And we know that this is the saturated liquid line, other side is saturated vapor line and both are merging at critical point. Now let us plot the enthalpy lines here. These two are the enthalpies of saturated liquid corresponding to PC and PE and these two are the enthalpies of the saturated vapor corresponding to PC and PE. We will now superimpose the simple VCR cycle 1, 2, 3, 4 on this pH diagram. Let us mark this point as 2'. We will now see what is the data that is available with us now. we have H4 is equal to HFC, H1 is equal to HGE. We do not have H2 available with us. In fact, this is what we need to compute. Then what else are available with us? We have S1 is equal to SGE, H2 dash is equal to HGC, T2 dash is equal to TC. Why? This is how the constant TC line will be. Until the 2 dash point, the temperature of the refrigerant will be TC. Beyond that, it will be greater than TC. And then we have S2 dash is equal to SGE. With the clarity we gain from the engineering analysis, let us now get on to engineering calculations part by adapting suitable equations, formulae, etc. First, the process 1-2, which is an isentropic process. So, S1 is equal to S2 is equal to SGE. The next is, let us consider the process 2-2 which is a part of the whole process 2-3, which is a constant pressure process. So, even 2-2 is a part of 2-3 process. This is a constant pressure process only. So, for constant pressure process, we have this expression from thermodynamic relations. So, let us substitute the data points that are available with us in this equation. We have S2 is equal to SGE, S2 dash is equal to SGC, CPV is known from property tables, T2 dash is equal to TC. Please note here I am using capital T here for temperatures. That indicates that the temperatures must be in Kelvin scale only. Therefore, here we have all the terms known, hence the T2 can be found in Kelvin. The next expression that is applicable to the process 2-2 is H2 minus H2 dash is equal to CPV T2 minus T2 dash. Substituting the known data points here, we have H2 is equal to HGC plus CPV T2 minus TC. From here, the H2 can be computed. Therefore, as H1, H2 and H3 are known now, RE, W and COP can be computed. So far we discussed with expressions and it could carry some abstractness in it. Let us eliminate that abstractness by putting some numbers into the process. Okay. Let us consider a R130 Fourier refrigeration system working between 40 C and minus 20 C, and we need to find the COP for that. So first task is to populate this table. Let us see what are the data that are given to us. We are given TC is equal to 40 and TE is equal to minus 20. For these reference temperatures, we need to collect the enthalpy and entropy values from R130 Fourier property tables. Now we have populated this table. Let us now get on to engineering analysis. As usual, we have the PCPE lines and TCTE lines. From the property tables corresponding to 40 and minus 20, we can have PC and PE lines, PE values. However, we don't need them, so I am not putting it here. Then let us mark the saturated liquid enthalpies and saturated vapor enthalpies corresponding to PC and PE. Now we will superimpose the simple VCR cycle 1, 2, 3, 4 and have this point marked as 2 dash. Let us now look at what are the data points that are available with us. H4 is equal to 256, H1 is equal to 385, S1 is equal to 1.74, H2 dash is equal to 418, T2 dash is equal to 313 Kelvin, and finally S2 dash is equal to 1.71. So with this information or with this data in our hand, let us get on to the calculation part. So first, 1,2 is anisotropic process, so S1 is equal to S2 is equal to 1.74. And for the process 2,2' we have this expression. Let us substitute the values that are known to us. So this gives us T2 is equal to 324 Kelvin. What is T2? It is nothing but the discharge temperature. And another expression for the process 2,2' is H2 is equal to HGC plus CPV T2 minus T2'. From here, we can compute H2 value as 430 kilojoules per kg. Okay. So, because now we are having H1, H2, H3 values, we can compute RE, we can compute W, and hence we can compute COP for this system as 2.1. With this lecture is completed, and if you have any questions, doubts, queries, etc., please feel free to write to me. The next topic is on a summary on COP of refrigeration cycles. See you then. Thank you very much.